So in this video, we are going to solve problems from exercise 2.2, which belongs to chapter number 2, polynomials. So first, let us see problem number 3. Verify whether the following are zeros of the polynomial indicated against them. Okay. So we are given different polynomials, p of x, p of x, p of x, and we are also given the values of x for every polynomial. And we have to verify if these values of x are zeros of the polynomial or not. So what do we mean when we say zeros of a polynomial? It means that the value of the polynomial will be equal to 0, okay, for let's say p of c, where c is some number. Okay, so for example, they have given these numbers -1 by 3, 1, -1, 0. For all these numbers, we will check if the value of the polynomial is equal to 0. If it is equal to 0, then we'll say that number is a zero of the polynomial, or it is also called as the root of the polynomial. Okay, so since there are a lot of questions to solve, we are just going to solve few of them. So 1, 3, 5 and 7. I'm going to solve only these 4 questions. Remaining 4 are quite similar, so you can solve on your own. Okay, so let's begin with the first question. The first question is p of x equal to 3x plus 1. So I'm just going to rewrite. So p of x is equal to 3x plus 1. Okay, and we are asked to find at -1 by 3. Okay, so now let's come here. So therefore, what will be p of -1 by 3? Okay, that will be equal to 3 into -1 by 3. So wherever there is x, you substitute -1 by 3. Wherever there is x, you substitute -1 by 3. Okay, plus 1. So that is equal to, so now this 3 and this 3, they will cancel each other out. So what remains is -1 plus 1, and that is equal to 0. Okay, so for this value of x, we have got the value of the whole polynomial as 0, which means that this is a valid 0 of the polynomial as per this definition. Okay, so I'm going to mark here tick mark, like yes, this is the 0 of a polynomial. Okay, so now let's erase this and continue. Okay, so consider this third problem now. I'm going to rewrite p of x as equal to x square minus 1. Okay, and we are given x as equal to 1 and -1. We are given two values of x, and we have to check if these two values of x are zeros of polynomial or not. So let us begin. First, we'll find p of 1. So p of 1 is equal to 1 square minus 1, that is equal to 1 minus 1, that is equal to 0. And we'll find p of -1. So p of -1 is equal to, so wherever there's x, we substitute -1. Wherever there's x, we substitute -1. So -1 the whole square minus 1. So -1 the whole square is 1 minus 1. That is also equal to 0. So once again, we have seen that for these two values of x, okay, we get the p of x as equal to 0, which means yes, as per the definition of the zeros of polynomial, these values of x are the zeros of the polynomial. They are valid roots of the polynomial. So once again, I am going to mark here as tick mark, and we are going to erase this. Okay. Now the next problem is this one: p of x equal to x square for x equal to 0. There's no need to solve this. If you put x equal to 0 in this, 0 square is going to be 0. So it's again going to be a valid root of the polynomial. So I'm going to just mark it tick mark. Now the last one which we're going to see is p of x equal to 3x square minus 1 for these two values of x. So let us try with this one. We have to find p of -1 by root 3. Okay, that will be equal to 3 into -1 by root 3 the whole square minus 1. Okay, now that is equal to 3 into, what is the square of -1? It is 1. Okay, so I'm going to maintain the bracket. Square of -1 is 1, and square of root 3 is equal to 3. So this will be 3, and -1 is as it is. Now once again, this 3 and this 3, they will cancel each other out. So what will remain is 1. So 1 minus 1. And what is 1 minus 1? It is equal to 0. So yes, this one, okay, the first one is definitely a 0 of a polynomial. Why? Because by substituting that value in the x, we have got 0. Now, let us erase this and let us calculate the next one. So, this is the next one, 2 under root 3. So, I'm going to say p of 2 under root 3, that is equal to 3 into, wherever there is x, you put 2 divided by under root of 3. Okay, the whole square minus 1. Now, once again 3 into, let us solve the square term. So, square of 2 is 4. So, 4 divided by, and square of root 3 is 3. So, 4 divided by 3 minus 1 as it is. So, this 3 and this 3, they cancel each other out. So, what we get is 4 minus 1, and 4 minus 1 is equal to 3. Okay, so by using this as our value of x, the p of x is equal to 3. It is not equal to 0. So hence we are going to cross this out. This is not the valid 0. This is not the valid 0 for this polynomial. Only minus 1 by root 3 was the valid 0. Okay. So in this way, we have solved the the third. We have solved the third problem from this exercise, where we wanted to just verify whether these values of x are zeros of the polynomial or not. Okay. Now let's move to problem number 4. I'm going to remove this. Yes. Now, problem number 4 asks, find the zero of the polynomial in each of the following cases. Okay, so we have to find the value of x such that p of x will be equal to 0. That is the definition of zero of polynomial. Now, how do we do that? In order to do that, we just assign p of x equal to 0. We just equate, or we substitute p of x equal to 0 and solve the equation. So once again, all these problems are very similar. So I'm just going to solve the first, the fourth, and the seventh one. The rest of them are quite similar. So let's start with first one. And the first problem is p of x as equal to x plus 5. Okay. So in order to find the zero of this polynomial, we simply say put p of x is equal to 0. We just say p of x equal to 0. Therefore, it will be x plus 5 equal to 0. And therefore x will be equal to minus 5. So x is equal to minus 5 is the zero of the polynomial, the first one. So I'm going to write that answer here. For the first one, it is x equal to minus 5. Okay, so let's erase this. Okay, now let's focus on the fourth problem. Okay, the fourth problem is p of x as equal to 3x minus 2. Okay, so once again put p of x equal to 0. Okay, therefore we get 3x minus 2 as equal to 0. Okay, now let's solve this equation. Therefore we get 3 of x as equal to 2. Okay, yes, 3 of x equal to 2, and therefore we get x as equal to 2 by 3. So x is equal to 2 by 3 is the 0 for this polynomial. So I'm just going to make a note here. For this polynomial, it is x equal to 2 by 3. Okay, now let's erase this, and now we come to the last one in this video. Yes, so the last one is p of x equal to cx plus d. So I'm going to write it down. This is the seventh one. Okay, p of x is equal to cx plus d. So once again put p of x as equal to 0. Therefore this is c of x plus d as equal to 0. Okay, and therefore now it will be c of x equal to minus d. Okay, and therefore x equal to, divide both the sides of equation by c. So we'll get minus d divided by c. So this is the value of x for which p of x will be equal to, for which p of x, yes, will be equal to 0. So this is our the root of the polynomial, or 0 of the polynomial. So once again, I want to just make a note here. For this, it will be minus d divided by c. And let's erase this thing now. So thus, we have found out the 0 of this polynomial in each case. In order to find the 0 of the polynomial, we have to just equate. We have to just put that p of x equal to 0 and solve for the value of x. So this is how you can solve the rest of the problems as well.